We're going to start off by talking about the fundamental theorem of calculus. And the fundamental theorem of calculus is basically just what we were building up to through that last lesson where we talked about how you can calculate areas under curves using the limit of the sum of all of the areas of those little rectangles, as well as that, that derivation involving the area function that we used as well. What the fundamental theorem of calculus states is that if our function f is continuous on a closed interval from a to b, okay, and we want to find the area under the function, area under the curve f from a to b, we can evaluate the integral from a to b of the function f at x dx, and that is in turn equal to the antiderivative of f evaluated at b minus the antiderivative evaluated at a. And this was like the last thing I wrote on the board in the last lesson. Okay? That basically tells us that we can evaluate integrals which we are using to find areas, okay, using antiderivatives at the endpoints. Okay, so the antiderivative at b and the antiderivative at a are the only thing that matter in terms of evaluating this integral. Okay, and I should also add here that, of course, capital F at x is the antiderivative of little f at x. Another way of writing that same statement is that if we do the derivative of capital F at x, we would get our original function f at x. But that's just what it means for something to be an antiderivative. Okay? Okay. So that is the fundamental theorem of calculus, and we're going to use this fundamental theorem of calculus to evaluate integrals. Now this is actually part one of the fundamental theorem of calculus. We're going to talk a little bit about part two a little bit later on. Save that.